In the Beginning by Dr. Walt Brown, we will look at the Black Canyon. The Black Canyon of the Gunnison. This is on page 144. Here at the Black Canyon, a picture is worth what does it say? A picture with a story. Here at the Black Canyon of the Gunnison in Colorado, cliffs are exposed for up to 2,700 feet above the Gunnison River. Their marble cake appearance comes from melted rock, primarily quartz, that was forced up through cracks in the darker rock. To appreciate the size of this cliff, notice the trees 10 to 15 feet tall at the top of the cliff. Now let's put aside all prior assumptions and ask, what caused this marble cake pattern? First, deep magma must be present or be produced. Second, the black rock must be fractured. This obviously takes gigantic forces acting over a large area, but the forces must be a special kind. A tensile stretching force would produce one crack, or at most a few evenly spaced cracks. At the instant of breakage, the pieces would scatter. Try breaking something by pulling on it. When it breaks, the pieces fly apart. This leaves us with only one viable type of force: compression. If compression forces acted equally in all directions, no breaks would occur. For example, deep sea creatures living under high compressive pressure inside and out are not crushed. Also, not crushed are many delicate pieces of pottery found in sunken vessels on the ocean floor. See the technical note, highly compressed solids, on page 616. So this is the canyon with 15-foot trees on the other side. If compression forces acted slowly but were almost evenly balanced, slight but slow movements would occur at the molecular level, a phenomenon called creep. The rock would slowly flow like putty until the force is balanced. Some channels or cracks are wider than others. Normally, the largest channels provide the least flow resistance, so all magma from below should have spilled out through them. Pump a liquid into a closed container until it cracks. You will see only one or at most a few major cracks, not many little cracks. If the magma had been in the chamber below just waiting for a crack to appear, the first crack should release all the magma, unless it solidified on its way up through the colder crack. There's the canyon. But if all cracks formed simultaneously, then magma would fill most cracks. All this leaves us with one conclusion for how the fracture occurred: rapid crushing. Next, magma must rapidly squirt up through the cracks in the black rock. If it happened slowly, or even at the rate a river flows, the front edge of the upward flowing magma would solidify, freeze, stopping the flow. If water is dissolved in any molten rock, its melting temperature is lowered considerably. Therefore, melted quartz with dissolved water would be more likely to complete the cold upward journey. Each channel or vein at the Black Canyon has a fairly uniform thickness. This reveals that the liquid's pressure exceeded the rock's pressure by nearly the same amount all along the channel. Again, this would not happen if the flow were slow or had consisted of cold tar. This marble cake appearance is exposed for at least 50 miles along the Gunnison River, so the compressive forces must have been about the same over at least those 50 miles. Magma, if it came from one spot below, would tend to escape through the shortest cracks leading to the surface. Instead, magma has filled cracks over a 50-mile range. Consequently, the magma source and any water were probably spread over a large area directly below. Because similar structures are seen where other deep basement rocks are exposed at the Earth's surface, these gigantic forces either cropped up many times at different places, or this happened once on a continental or global scale. The parsimony criteria, seeking the simplest explanation, leads us to favor one big event. We will call this the compression event. We can conclude that this crushed rock was rapidly crushed over a wide area. Magma probably contained dissolved water, was then quickly injected up through the cracks. In studying this effect, an immense layer of marble cake rock, we tried to deduce its cause. One can easily err when reasoning from effect back to cause. Another approach, reasoning from cause to effect, requires starting assumptions. We began this cause to effect study of the flood on page 134 with only 3 assumptions, and then looked at their logical consequences. When cause to effect reasoning is consistent with effect to cause reasoning, as it is here, confidence in our conclusion increases greatly. The inner gorge of the Grand Canyon, the same marble cake pattern exists in the inner gorge of the Grand Canyon, but with less color contrast than the Black Canyon of the Gunnison. That's in the beginning, the compression event of the Gunnison Black Canyon of the Gunnison, and also the inner gorge of the Grand Canyon, pages 140 something, from In the Beginning by Dr. Walt Brown, and you can get a flip book of this for free at hpt.rsr.org.